I'm really excited to be here, and thank you to React Day organizers for having me. I'm just really excited to join in the conversation about internationalization and data visualization. So as you just heard, my name is Naomi Meyer, and I work as a software development engineer at Adobe in New York City, where we use a lot of React. Yeah. So I'm Nae_Omi, Naomi online, and I'd love to keep the conversation going. And this is my website where I will post all my slides with lots of resources, so feel free to check that out later. On my team, I work as the product leader or champion for internationalization. So I've been thinking a lot about localizing strings and correctly formatting content across locales. But about 6 months ago, I was tasked to build a new feature, a data visualization that looks kind of like this example from D3. And so it got me kind of down a rabbit hole, thinking as much as I can and reading and researching everything that I could find about sort of the intersection between internationalization and data visualization. And I think it's really fascinating because of kind of the cultural implications of how we think about elements that are involved in a data visualization and how critical it is to make sure that that information that the stories we're telling with our data visualizations, that they are clear and not misunderstood or misinterpreted by diverse audiences of users across the world, and how important it is to make sure that they are correctly sort of translatable, because our data visualizations are often used in the context of news and really important information. So this is kind of an example of what I'm talking about. This is a great visualization that's on The Guardian, a website, and it looks good, right? Well, if we go into the browser and we translate it into Chinese, we see a few localization or internationalization issues. So first we have numbers. These are really important to format correctly for each locale. And then colors. So colors can have different cultural significance that can really vary across regions. And of course, dates and times need to be handled correctly for each region. And if we take this same visualization and we translate it in the browser into Arabic, we can see some right-to-left challenges. So these are challenges that should be addressed. And clearly, there's other sort of internationalization issues like the translation of text and strings, but I'm not going to go into that specific content today. Instead, we're going to talk about first definitions, and then numbers, dates and times, right to left, and then go into iconography and some emojis, and then we'll end with colors. So overall, the aim of internationalizing our data visualizations is to create experiences that are equally usable, relevant, and meaningful for diverse audiences of users across the globe, to really amplify the voices of our global audience. And I'm not going to get into the guts of D3 or React Vega or React Viz specific visualization tools, because instead I want to provide solutions that can be used across visualization tools. Because overall, my goal today is to encourage you all, my fellow React coders, to join me and really think broadly about how we can build visualizations that can be easily translated for users across the world. And I really hope that we can all strive to sort of avoid our assumptions about colors and text and numbers. So on adobe.com, and many of our Adobe products, we support over 60 distinct locales. And this is the paradigm that we often talk about at Adobe for internationalization, where we have first translation, the most granular level, followed by localization, internationalization, and those all kind of fall under the umbrella of globalization and our numeric acronyms. So the more I look at this and I think about it, I think there's sort of an additional umbrella or another higher order component, if you will, and that's accessibility and innovation. So culture is deeply rooted in our thinking patterns, and it affects how our users interact with and benefit from our digital experiences. So internationalization really goes beyond translation. And by acknowledging and celebrating these cultural differences, we are creating for accessibility. And you might be wondering why I added innovation there. And that's because many of the products that we love today across the world, things like touchscreens, text messaging, voice assistants, those were originally built for accessibility for people who are kind of differently abled. So by building for accessibility and really broadening our minds, we are truly innovating. Also, if we look at these two visualizations, they kind of tell different stories. So the bar chart on the right shows that the majority of people on Earth do not speak English as their first language, whereas the pie chart shows that the majority of websites and digital content are in English. So I look at this and I see an opportunity for us to expand digital content, expand the internet into different languages. So let's talk about how we do that. Let's go over numbers around the world. So this is a visual representation of some of different numbers and how they really vary across the world. And I look at it and I think numbers are beautiful. So instead of hard coding or directly displaying an integer in a JavaScript application, we can use the JavaScript native API called the INTL object. And we can build this reusable formatter instance of the intl.number format tool, and this supports locale-aware formatting. And since it's enabled creating a reusable formatter instance, it's more efficient than other methods. So if we take this reusable formatter instance into a variety of different locales and format this long number of 123 trillion, we can see a variety of differences across locales. So in English, we include a comma every third integer. German, we see a period. Russian, there's a space. And then if we look at Tamil and Hindi, this one makes me smile because the comma is included in a different location within the integer. And that's because they have a different number ordering system. So the display of large integers is different. So let's look at another example of how we can display integers. So here we have Gapminder, which is a beautiful, common, amazing data visualization tool. And this is in English. And then we can go in and translate it into Russian. And it looks great, but there's a little internationalization bug here. So I've highlighted in red, the axes has 16,000 and 32,000, which includes a K for 1,000, which is what we do in English, but that's not the correct way to shorten 16,000 in Russian. And we can see the same bug in the Arabic translation of Gapminder. So JavaScript to the rescue, we can use that same intl.number format function to get locale-specific symbols. And this is by passing in the notation compact parameter. And this is a really exciting experimental addition to JavaScript that's not fully browser compatible yet, but I hope as a JavaScript community we can continue to use notation compact and expand it into new browsers because it's very exciting and it's very useful for data visualizations because often we want to take these large numbers and make them more human-friendly. Like we saw on the X and Y axes in the legend, in the tooltip on hover, we often want to use notation compact to make our numbers shorter. So this is how it looks across a variety of locales with the locale-specific symbols. And as we can see, again, significant variety. In Tamil and Hindi, again, the comma is included in a different location. And then we see in Arabic and Farsi, the text is reading right to left. And Farsi is using the Eastern numerals or Eastern Arabic numerals. Similar to notation compact, we can also add notation scientific. And here we're including the style as unit and the unit as meter per second. So this is recommended instead of hard coding our scientific notation. Similarly, we can pass notation as engineering. And these are actually included in the TC39 proposal for ECMAScript from Matthias Baynards and Shane Carr at Google. And I just want to shout them out for doing amazing work to really increase the functionality of the INTL object. So here we have a visualization of a well-localized graph where in red I've highlighted the units are correctly formatted into Japanese. So let's move on to dates and times around the world. So time zones. That's the perfect reaction. Here we have a bright, colorful, jarring example of time zones, which I think is perfect because they are notoriously confusing in computing. So here we can see a representation in the ocean of the 25 nautical time zones that are separated by lines of longitude. And then most time zones on land have a standard time offset from UTC, or Coordinated Universal Time. And most are by whole numbers of hours, so UTC plus 8, UTC minus 6. But several land time zones are offset by 30 minutes or 45 minutes from the nearby hourly offset. And then if that's not confusing enough, time zone is not always equal to offset from UTC. And that's because many time zones have more than one offset because of daylight saving times and summer times rules. So this is actually a bug that I fixed on my team at Adobe, where we were displaying a graph with a line for today, but the user's today was not always correct because of certain time zones. So it's really important to get this right, and it's notoriously difficult. So definitely read more about time zones if you're interested. And then, of course, the classic question, what day is it today? And it depends on where you're asking, right? Sometimes this is December 6th, sometimes this is June 12th. And again, that's something that you really want to get correct. So we can use the JavaScript INTL object. Here is the date time format functionality, where we're passing year as numeric, month as short, and day as numeric. And then we can pass in a start date and an end date, which is something we often do in data visualizations, and format the range. So here we have December 3rd through the 6th formatted across locales. And I look at this variety, and it just makes me smile. But we have a number of JavaScript and React tools that can help us. These are the ones that I use and I really like, but I know that there's a lot of great open source projects. On my team at Adobe, for a lot of our internationalization challenges, we use React INTL. And of course, Moment.js is excellent, very popular open source tool for formatting dates and times. And React recently, the React team, I don't know if it's a React team, but Facebook recently open sourced their FBT, or Facebook Translate, which is great to use within React for internationalization. And then final shout out, the JavaScript, ECMAScript out of the box has the INTL API, which there's a lot in here. I really encourage folks to read more about it on MDN. And as a JavaScript community, I hope that we can continue to expand the INTL API because it's so useful. Instead of importing additional libraries that can negatively impact performance, by using JavaScript, we have everything there. So let's move on to right to left around the world. So Arabic is the 5th largest language in the world. Grab some water. And then if we add Pashto, Urdu, Farsi, and Hebrew, there's nearly 700 million Arabic speakers in the world. And that's a huge customer base to expand to new markets from a business perspective. It's also a lot of people that, by using right to left, they're going to have a much better experience navigating in their native mother tongue. So this is a classic example of right to left, and it's a story that I've heard a lot. I don't know if it's 100% true or not, but the story goes that there were some Coca-Cola advertisers who went to Saudi Arabia, and they built this storyboard where they wanted to advertise in Saudi Arabia, and they said, okay, in a left to right context, the storyboard would be read, someone is lying on the desert, they drink Coke, and then they're happy and running. But they forgot that in Saudi Arabia, people speak Arabic and read this right to left, and the story goes, someone's happy and running, they drink Coca-Cola, and then they're lying on the desert. So it was kind of a fail of right to left. Here's another fun example from Lebanon, which is a great infographic. And we can see all the text is reading right to left, and then the icons are also right to left, where we start on the green and move to the red. And right to left is sort of a mental shift for many of us who are native left to right speakers. So as left to right speakers, we often look to the top left of the page, but right to left speakers will look to the top right of the page. So we have to kind of think about how to handle that in our UI. And that's true for text, but many RTL languages are bidirectional. So in English, German, Spanish, they're monodirectional languages where everything reads left to right on the page. But the many right to left languages are bidirectional, where the characters and text is reading right to left, and then the integers are left to right. So there's two directions happening simultaneously on the page. And then in many apps and data visualizations, we include user-generated content. So if we have like a name that's been written in English, we have to handle English left to right, and then text right to left, and then integers. So there's a lot of different directions happening simultaneously in line. So I think this is a great way to visualize that. Oh no, video cannot be loaded. OK, well, this is from Muriel Schotlinger, who's a brilliant engineer leading the charge on right to left. And she shows, you can't see it, but she's writing text right to left, and then numbers left to right. So we can see how that looks in a graph. So here's an example of a Hebrew language 5th grade math book. And in orange, we can see on the top the title is bidirectional, and then the mathematical notation is also bidirectional. So the characters are reading right to left, and then that multiplication and fractions are left to right. Differently, if we look at a high school calculus book from Jordan in Arabic, everything is right to left. All of the numbers and text and characters, including the square root sign up there that's mirrored, that just makes me smile. Everything is right to left. And the X and Y axes are labeled with Arabic characters. We're using the Eastern Arabic numerals here. But then the actual graph itself, the chart, is intended to be read left to right. Differently, we can see this example in Hebrew, where the X and Y axes have been changed, and everything on the page is right to left, including all the data and the axes. And then this example is from the Maldives Anti-Corruption Commission in the Dheveli language. And the X and Y axes read left to right, but if we look at the colors, it's intended to be read chronologically, so the story of the viz goes right to left. So for me, that just blows my mind the more I think about right to left. And it's really important to handle it in our data visualizations if we support users who are read right to left. And overall, just to kind of avoid our assumptions about how text should be read or the direction of the axes. There's some great open source tools. These are the ones I'm familiar with, but I'm sure there's many more. If you can think of any or if you know of any, please let me know. Airbnb has the React with Direction. And then Kent Dodds has the RTL CSS JS tool that are great libraries. So let's move on to iconography. All imagery and iconography are closely related to society, culture, beliefs, religion, and political values. And that's why it's so important to be careful and intentional about selecting images for different regions. So these are examples from Adobe's design system that's called Spectrum. And this image shows pictures of people. And the best sort of advice is when picking pictures that include people to make sure that those people are dressed appropriately for the region. And to remember that the definition of what is appropriate dress can really vary across regions. And then this image on the right would be commonly used in a Western context of relaxing or kicking back. But in parts of Southeast Asia, and particularly Thailand, displaying the soles of your feet are considered very rude and offensive. So this would not be an appropriate picture to show respect in Thailand. Similarly, the definition of what is correct or incorrect can change. So this is one that really got me because I was working as an English teacher in Japan. And when I first started, I was marking my students' homework. And I used a check, which is what I would do in the United States, as yes, that is correct, that is good. But I quickly realized that in Japan, people use a circle to indicate that that is correct. And so I had to go back and fix the markings that I had done wrong on my students' homework because their parents called me. So, what is correct or incorrect? Sometimes it's a check, sometimes it's a circle, sometimes it's an X, and that's something you really want to get correct. So let's move on to emojis. I think emojis are really fascinating because they are used by billions of people online every day across languages, across the world. So we have a lot of really interesting data about how emoji usage varies across regions. And Ben Metlock from SwiftKey Keyboard and Gretchen McCullen, the author of the book Because Internet, which I highly recommend, they have this research on the linguistic secrets in emojis. And their research indicates that these 4 emoji categories are used more heavily in certain regions and languages. Can you guess which ones? So heart emojis are used 4 times more by French speakers than any other language, right? Paris is the city of love. And then flower and plant emojis are used 4 times more by Arabic speakers than any other language. And drug emojis are used most in Portugal Portuguese and Australian English. And these are also countries that happen to have some of the most permissive drug laws in the world. And finally, Santi emojis. These are used most in Danish, Norwegian, and Swedish, which is where he lives up in the North Pole, right? So there's another interesting study called Assessing the Meanings of Emojis for Emotional Awareness. And the authors hypothesized that of these 9 emojis that include emotion, the respondents would perceive them differently across gender and age. And they found that to be true for 3. So the unamused face and the face screaming in fear had an age variant where older and younger users interpreted it differently. And then the face with rolling eyes had a gender variant. So Jennifer Daniel is an amazing creative director at Google who's leading the charge to include more gender-inclusive emoji code points in the newest version of Unicode. And she says that storytelling is for the people. And this peach emoji is often used in the context of sort of a suggestive emoji because it looks like a butt. But we've seen in the United States an increase in the peach emoji used in the context of impeachment. So emojis can be changing and are dynamic. And that's why it's really important to be aware of the current context of an emoji. A good rule of thumb is to try and avoid gestures, sarcasm, and slang, because these are really difficult to translate, and they're often mistranslated. So an example I think of that's very useful is so where I grew up in the United States, this means yes, and this means no. But I actually have a lot of coworkers who grew up in India, and they have sort of an Indian head shake that looks kind of like what I would think of as no, but for them that means yes, or okay, or I understand. And so gestures can really vary, and they can actually have opposite meanings in different regions. So that's why it's kind of, if you're working in a global audience, best to try and avoid those. Similarly, hand gestures can have a variety of meanings across regions. And so the Anti-Defamation League has their hate database. And they have a list of hate symbols that I think are important to kind of do your homework and just be aware. Like, for example, Pepe the Frog or the OK hand symbol are in their database of hate symbols. So it's really important to just do your homework and make sure you're not accidentally using a symbol or an emoji that might have an alternative meaning that you don't intend. So let's move on to colors. Colors are a major factor in creating effective data visualizations, but colors can have significant cultural meanings and differences across the world. So who remembers the great dress debate of 2015? Right, this was an internet controversy where half of the internet saw this dress as white and gold, and the other half saw it as blue and black. And this kind of made us more acutely aware of our brain's processing and the neuroscience of vision and color. So Cassia St. Clair talks about this in her book, The Secret Lives of Color, which is a beautiful book I highly recommend. And she says colors should be understood as subjective cultural creations. And I could talk your ear off about color, and there's a lot of really interesting examples, but I'm just going to go over a few extremes today, but ask me later. So an extreme example is the color red. In Western contexts, in North America and Europe, often red is used as a stop sign. It's warning, danger, error messaging. But here we have an image of a Chinese wedding and a Chinese red envelope. So during the Chinese New Year, people put money in the red envelope. So red is a color that's associated with prosperity and wealth and happiness and good luck. Similarly, in the middle, we have an image of the ancient Inca deity Mamahuoco, who is said to have emerged from the cage of origin wearing a red dress. So in some cultures, red is bad, and in some cultures, red is good. Also white. So here's an example of a Hindu funeral in India where all of the people who, the family members of the person who have died are wearing white. And in parts of Hindu culture, widows are required to wear white. And then a traditional Chinese funeral where all of the family members of the person who have died are also wearing white. So, in some cultures, white is a color for death and funerals, and in other cultures, like in the West, white is a color that, is worn during weddings and has different connotations. And the color purple. So the Vatican is dressed in purple for Lent, and then there's this funny story of Julius Caesar. When his son was born with Cleopatra, he wore Tyrian purple robes, which were very expensive to make, and so they outlawed purple across the land. So if any peasants were seen wearing purple, they could face death. And now purple is a color associated with bad luck in parts of Italy. So how can we handle this in React? We have tools, either CSS variables or styled components, however you want to do it, to change the color theme in our React apps, to go from dark mode to light mode. And we could take this same logic and apply it to languages. So here's a simple markup where we have language tags, and we can use CSS to grab the language with the pseudo class or the lang selector. And here we're loading different font families, which is very common to load additional fonts for different languages. But technically, it is possible to load additional color themes or modes for different color cultures to be human-centered in our design of our data visualizations for a global audience. So I have this function that is internationalizing our data visualizations for a global audience of users across the world, will return improved experiences and amplified voices of our international users. So I really hope that we can all strive to broaden our minds and to avoid our assumptions about what colors and emojis really mean, the way text and X and Y axes are supposed to be directed, and how to format numbers and dates and times, and just try and broaden our minds to work under a global audience. So thank you so much.